A grade recovery assignment has been given to several students. They must enter their assigned number. There are numbers between 1 and 200. Each student has been assigned their own. They will be doing 3 balancing questions. They vary in length, and the score will adjust accordingly for your student. After that, there's a percent composition problem. Each percentage is worth 5 points because of the amount of work to do part over whole times 100%. For this one, my example, I have H4B6O11. I accidentally did the wrong number of hydrogens. Since hydrogen is the smallest molar mass, any little change is going to be quite significant. So when I enter in its percentage to begin with, it won't give me any points. I did the boron and the oxygen correctly, and their percentages were not affected adversely. Notice I have 10 out of 15. Once I correct the hydrogen, it fixed itself. After that, there's an empirical formula. I've changed the format a little bit from the original digital worksheet, where steps 1 and 2 are on the left, but step 3, where you simplify your molar ratio, is on the right now. Beneath that, once you've determined what your simplified molar ratio is, you're supposed to enter in a whole number ratio for the subscripts. Some students will have to go ahead and multiply their simplified ratio by 2, 3, 4, or 5 in order to get a proper whole number ratio for the subscripts. Remember, as you work through steps 1 and 2, you'll be figuring out the moles of each element type and assume a 100-gram sample so that you can just simply turn your percentages into gram amounts at the beginning. Moles count, so we'll do this first. And once we've got the mole amounts, we actually have a legitimate ratio. The problem is it usually has decimal points. The simplification is easily done by dividing all of the mole amounts by the smallest mole amount. After that, there's one stoichiometric problem. You will start with grams of one thing and end with grams of another. Here we're moving from 86.84 grams of oxygen to grams of water. I'll start my dimensional analysis by setting up what I have to begin with, and my unit goal at the end by selecting grams of the water. When I set about moving through my dimensional analysis, my conversion factors, I know that grams of oxygen has to go, and the first place and only place that I can go from grams of oxygen is to moles of oxygen by using the molar mass. Once into moles, I'll need to cancel out moles of oxygen and move to something else. This is the crucial point of stoichiometry. We'll get our relationship from the balanced chemical equation up at the top. There are 6 moles of water for every 3 moles of oxygen. Once into moles of water, I'll be able to use the molar mass of water to get to grams of water. For every 1 mole of water, there's a certain number of grams of water. I can multiply across the top, divide by the product of the bottom, and I'll get my answer for grams of water. I've now completed everything, and while nothing really changed color, you can see my point values have been counting up, so I have an idea of what I'll get at the end. As the instructor, I will type something special into this box to make the score no longer pending. It'll also allow things to turn green. Nothing will turn red. I didn't have the opportunity to make that happen. But if something doesn't turn green, it tells me that something is wrong.